today we are not doing any graphing, but we are looking at graphs, and we are going to do more with vocabulary. The last lesson taught us some vocabulary, but this vocabulary is quite different. But you should have heard a lot of this vocabulary back in Algebra 1. And if you forgot, that's okay, because that's what the lesson is for. All right, so first of all, these graphs down here are called parabolas. So parabolas are U-shaped graphs. Either it opens down or it opens up. So that is what a parabola is. These are also quadratics. So anytime you see a parabola, that means that the highest exponent is a 2, like we talked about in the last lesson. If the highest exponent is a 2, it's called quadratic. Okay, so the axis of symmetry is a line that splits the parabola in half. And on both of these graphs, it happens to be the y-axis that splits the graph in half, but it's not always. Like if I showed you this one down here, the axis of symmetry is still the line that splits the parabola in half, but you can see it's not the y-axis this time. Okay, so one thing I do want you to know, the axis of symmetry always goes through what's called the vertex. So the axis of symmetry always goes through either the highest point of the graph or the lowest point of the graph, and that's what a vertex is. So the vertex is the highest point, or the vertex is the lowest point of the graph. If the vertex is the highest point of the graph, that is called a maximum. And if the vertex is at the lowest point of the graph, that's called a minimum. And hopefully that makes sense in your head. If it's the highest, it's max, and if it's the lowest, it's minimum. But it all depends on where the vertex is. Okay, so one thing I wanted to go back and say about these axis of symmetries. These axis of symmetries that split your parabola in half, those are all called vuxes. They're vertical lines with undefined slope, and that means they would have the letter x equals for their equation. So this axis of symmetry, you're going to use x equals, and everywhere on this line, your x has a value of 0 because you're not right or left. So every time we see an axis of symmetry, for parabolas anyway, it's going to be a vertical line, so that's called a vux, which means I'm going to use the letter x equals. So once again, this is going to say x equals, and then everywhere on this line, the x is a 0. Okay, and then we're going to do a little bit other vocabulary called a corresponding point, but I'm going to talk about that as I just get started. And then we are visiting domain and range, and we're going to do inequality notation as well as interval notation. All right, so here we go. So the vertex, it's either the highest point or the lowest point of the graph. And in this picture, the vertex would be the lowest point. It's where the curves come together. All right, so this is our vertex. To get there, I go right 2, so my x is a 2, and then I don't go up or down, so my y is a 0. Because this vertex is the lowest point of the graph, it's called a minimum. Now, this wants to know the max or min value. So we're trying to figure out how high or how low something is. That's what max and min are asking about. How high is something or how low is something? So what talks about high and low? An x number or a y number? A y number, because the y-axis runs up and down. So I want to know the y value right there. And it's 0. So that's how high this graph is. It's 0 high. Okay, the axis of symmetry, remember it's the vertical line that splits the parabola in half. All vertical lines are vuxes. So it's going to use the letter x. So x equals, and then everywhere on this line, what's your x value? 2. Okay, so one thing I want you to know right now, and I will say this numerous times in this lesson as well as once we start graphing parabolas for ourselves. Whatever the x-coordinate is to the vertex, that's always the same as the axis of symmetry number. And it's because the axis of symmetry runs through the vertex. So they have to have the same x value. And then the max or min number is always the same as the y-coordinate of the vertex. And that's because the vertex will always be the highest or lowest spot, so that's why the vertex is always the max or the min. And the reason I want the y is because the y tells you how high something is or how low something is. Okay, now P and Q. We're trying to find the points that are corresponding to P and Q. They're also called their reflection points. So I'm just going to write that here. Reflection points. So I don't actually want to know where P is. I want to know where does P land if you flip P over this axis of symmetry. And I'd have to go right one to hop on the axis and right one to flip it. And this is where P would land, which is right 3 up 2, so it's the point 3, 2. So the axis of symmetry splits your parabola in half, meaning you're going to have one point the same distance from the axis of symmetry as the other point is on the other side. Okay, let's find Q's corresponding point or reflection point. So to flip Q, I have to go left 2 to hop on the axis of symmetry. So left 2 again, and Q would land right here. And you don't go right or left, so your x is 0, but you do travel up 8, so your y is at 8. And these are the corresponding points to P and Q, also known as reflection points. Okay, domain. Domain is talking about x's, so we're looking left and right because the x-axis runs left and right. So as I move my marker to the left, I hit an arrow, so I go forever left. As I move my marker to the right, I hit an arrow, so forever right. So this graph goes forever left, forever right. That's called all real numbers. The other way of writing that is when you go forever to the left, you get smaller, 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 so you're headed to negative infinity. And when you go forever right, you get bigger, 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 so you're headed to positive infinity. And remember, infinities always have parentheses. Okay, range, these are our y's. So now we're looking up and down because the y-axis runs up and down. So I can see this graph goes forever up, but not forever down. This is my lowest spot that the graph goes. So I want to know the y value there. What's your y value right here? 0. So your y starts off equaling 0, and then when you go up, up, up on this side, or up, up, up on this side, your y's get greater. Okay, for interval notation, the lowest y you have is at 0, but when you go up, 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 and get bigger, 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 you're headed to positive infinity. So I always want smaller number, bigger number, so 0 is smaller than infinity, so it's going to be 0, infinity. This is a point, so it's a closed circle, so it gets a bracket, but you can never equal infinity, so infinity is always a parenthesis. Do you know what other kind of graph had this same kind of domain and range answer? There was another graph that had this exact same kind of domain range answer. It was our absolute value graph. Remember when we had the absolute value bars like this? And those were V-shaped graphs. Those also went forever left and forever right. And the range looked very much like this kind of thing. Okay, let's just try some more. All right, so let's start with the vertex. The vertex, remember, it's the lowest point or the highest point. So this time, once again, it's the lowest point. I go right 3 and up 2 to get there. So that's the point 3, 2. Since this is the lowest point, it is called a min. And I want to know how high or low it is. So what's the y value right there? 2. So remember, I told you a minute ago, whatever the y-coordinate is to your vertex, that will always be your max or min value. All right, the axis of symmetry is this vertical line that splits your parabola in half. Remember, all vertical lines are vuxes. Vertical line, undefined slope, x equals for the equation. So it's going to say x equals, And then what's your x value everywhere on this line? Your x is a 3. Okay, so now I want to flip P and Q over the axis of symmetry to find their corresponding points or reflection points. So let's start with P. To get to the axis of symmetry, I have to go right 2, choop, choop. So I go right 2 again, choop, choop, to flip it. And this is where P would land. So you go right 5 and up 6. So that's the point 5, 6. That is P's corresponding point or reflection point. Okay, now let's find where Q would land. To get to the axis of symmetry, I have to go left 1, choop. So I go left 1 again, choop. And so this is Q's corresponding point or reflection point. So I have to go right 2, up 3. So that's the point 2, 3. Okay, let's look at domain. So remember, domain are x's. You're looking left and right. As I go to the left, I see an arrow. I go forever left. As I go to the right, I see an arrow, so forever right. So forever left, forever right. That's called all real numbers, which is also negative infinity, comma, positive infinity. Okay, range. My graph goes forever up, but not forever down. That's the lowest it goes. So what is my y value there? Because range is about y's. So what's my y value? Right there. My y value is a 2, and it equals it. And then when you go up, 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 your y's get greater. So the lowest y is 2, and when you go up, 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 you're headed to positive infinity. So that's going to be 2, comma, infinity. Infinity is always a parenthesis, and closed circles are always brackets. And then one other thing I wanted to remind you, whatever the x-coordinate is to the vertex, that's always the axis of symmetry number, which is going to be a very important concept when we go to graph these parabolas for ourselves. Okay, let's just keep practicing. All right, this one. The vertex is either the lowest or highest point. This time it's the highest point. So to get here, I don't go right or left, so my x is 0. I just go up 8, so it's 0, comma 8. Since this is the highest point the graph goes, that's called a maximum. Well, how high is it? It's 8 high. So remember, the y-coordinate of the vertex is always the same as the max or min value. Okay, let's do axis of symmetry. So the axis of symmetry is the vertical line that splits your parabola in half. All vertical lines are vuxes. So I'm going to use the letter x. So x equals, and what's your x everywhere on this line? 0. Okay, now let's flip P and Q over. So P, you go right 1 to hop on the axis, choop, right 1 again to flip it, choop, and what point is that? 1, comma 6. You go right 1, up 6. Okay, now I want to flip Q over. So Q, you have to go left twice, choop, choop, to hop on the axis. So go left twice again, choop, choop. And what point is that where Q lands? Negative 2, comma 0. You go left 2, but you don't go up or down. Okay, now it's time for domain and range. So domain or x's, we're looking left and right. So as I move my marker to the left, I hit an arrow, so I go forever left. As I move my marker to the right, I hit an arrow, so I go forever right. So if I ever go forever left, forever right, that's called all real numbers, which is also negative infinity, comma, positive infinity. So it doesn't matter if a graph opens up or if a graph opens down. The domain is always all real numbers, because this one goes forever left, forever right. This one also goes forever left, forever right. So the domain will always be all real numbers for all of your parabolas. Okay, now range. Range are your y's, so now we're looking up and down. Now this graph goes forever down, but not forever up. So I need to find where my highest y is. So what's my y at the highest spot? 8, so it equals 8. And then what happens when you go down? Y's get less. Okay, so this graph, when the graph went up, y's got greater. But this graph, when the graph goes down, y's get less. Okay, so when you go down, 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 you're getting smaller, 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 so you're headed to negative infinity. So we started up here at 8, and we go to negative infinity. Which of these numbers is smaller? Negative infinity. So it's negative infinity, comma, 8. Infinities are always parentheses, and closed circles are always brackets. So when a graph opens down, you'll go to negative infinity. But when a graph opens up, you'll go to positive infinity. And positive infinity is the biggest number there is. That's why it will always be on the right. And when you go down and go to negative infinity is the smallest number there is. So negative infinity will always be on the left. How are you feeling about this lesson? Okay, let's just do one more for good measure. All right, so the vertex. What do you think it is? It's the highest point, and you go left 2, down 2. So it's negative 2, comma, negative 2. Is it a max or a min? It's a max. It's the highest point. And what would you say the max value is? Negative 2. That's how high it is. That's its y value there. So remember that the y coordinate of the vertex is always the max or min answer. Okay, the axis of symmetry is the vertical line that splits your parabola in half. And what do you think the equation to that is? X equals negative 2. Remember, all vertical lines are vuxes. So you're going to use the letter x equals in your equation, and everywhere on that line, the x is a negative 2. And I want to remind you that the x coordinate of the vertex is always the axis of symmetry number. I forgot to remind you up here, so I'm going to do it now. The x coordinate of the vertex is always the axis of symmetry number. Okay, so now let's talk domain and range. So domain are x's, so remember you're looking left and right. What do you think it is? All real numbers. You go forever to the left, forever to the right. And the other way of writing that? Negative infinity, comma, positive infinity. And infinities always have parentheses. Okay, now how about the range? Range are y's, so now you're looking up and down. So y less than or equal to negative 2. So this is our highest y, and the y value there is negative 2. And then when the graph goes down, the y's get less. Okay, what do you think about interval notation? Negative infinity, comma, negative 2. Yep, you start at the negative 2. That's your y value there. And when you go down, 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 you're getting smaller, smaller, smaller. So you're headed to negative infinity. Remember, it's always smaller number, bigger number. And then infinity is always a parenthesis, and closed circles are always brackets. So that's the end of that lesson. Smiley face.